solving quadratic equations with factorising. So we're going to use the concept that if a times b equals 0, a has to equal 0 or b has to equal 0, or both. Let's have a look at this question. X squared minus 4x equals 0. So here's a quadratic equation we have to solve for x. Now, when we have two terms, usually we just want to pull out a common factor. So here we can pull out x, which leaves behind x minus 4. And here, we now have a product equaling 0, just like above. So either this has to equal 0, or this has to equal 0. So we can write two mini equations now that we have to solve, each with its own, which each of the terms of the product. So x has to equal 0, or the x minus 4 has to equal 0. So this gives us one answer, and we just have to solve this equation here, plus 4 to both sides. So x equals 4. So we can say that the solutions to this equation is x equals 0 and 4. What about x squared minus 9 equals 0? Well, this is a difference of two squares, so we can factorize this straight away by saying that x plus 3 times x minus 3, and again, we have the product of two things equaling 0, so either this has to equal 0 or this has to equal 0. And solving the first one would give us x equals minus 3, and the second one, x would be 3. You can write out the equations every time, or you can skip straight ahead. What about 2x squared equals 50? So in order to solve the quadratic equation, we like it one side to equal 0. So that's minus 50 from both sides. So we're going to get 2x squared minus 50 equals 0. Now we can take out a common factor of 2, where we get x squared minus 25 equals 0, all times by 2. Let's go ahead and divide both sides by 2. The 2's will cancel. We get x squared minus 25 equals 0. 0 divided by 2 is 0. And now we have the difference of two perfect squares. So we can factorize that with x plus 5, x minus 5 equals 0. And solving for each one of these things equaling 0 gives us x equals minus 5 or 5. What about x squared plus 2x plus 1 equals 0? Well, here we have a monic quadratic trinomial, where in order to factorize it, we need to look for two numbers that multiply to this number and two numbers that add up to this number. So let's go ahead and write some brackets and x in. And two numbers that multiply to 1, well, that can only be 1 and 1, and both being positive would make them add up to 2. So here, x just equals minus 1. They're both the same. They both give us minus 1. We don't have to write it twice. What about x squared minus 5x plus 6 equals 0? Another non-monic quadratic trinomial, which we can write a set of brackets, equals 0, x and x, and we're looking for two numbers that multiply to 6 and add up to minus 5. Well, that's going to be minus 2 and minus 3. Because minus 2 times minus 3 gives us 6, and minus 2 plus minus 3 gives us minus 5. And solving each of those binomials for 0 gives us x equals 2 or 3. What about 6x squared plus 7x minus 20 equals 0. Well, this is a non-monic quadratic trinomial, and in order to factorize this, I'm going to use the method we learned for non-monic quadratic factorising, where we're going to multiply the coefficient of x squared by the constant, which is going to give us minus 120. And because it's 6x squared, we're going to go 6x, 6x, all over 6 equals 0. Now we need to look for two numbers that multiply to negative 120 and add up to 7. So because this is big, let's look at a way that can help us. So we're looking at factors of 120. So I like making this little diagram, and pick any two factors you want. We can pick, let's pick 60 and 2. Add up the numbers to get 62, find the difference, 58, and if either one of those is the number we're looking for over here when they add up or subtract, we know we've got the right two numbers. So this doesn't give us 7, so we need two more factors. And to get more factors, you can divide one of the factors by a number and multiply the other factor by the same number. So I might go ahead and divide this one by 2 and times this one by 2, and that automatically gives us more factors. So we're going to get 30 and 4, add them up, gives us 34. Find the difference, 26, none of those are 7, so they don't work. Let's try dividing this one by 2 and timesing this one by 2. That's going to give us 15 and 8. If you add them up, it's going to be 23. And if you find the difference, that's 7. And that's exactly the number we're looking for. So these are going to be the numbers we need for our factorization. We just need to work out the signs of them. So we know it multiplies to a negative number, so we know one of them has to be positive and one of them has to be negative. The number we need to add to is positive, so automatically the bigger number has to be the positive one, which means this is the negative one. And we can even double check. 15 times negative 8 is negative 120, as we've just shown here, and 15 minus 8 is positive 7. Now we can go ahead and factorize out any terms in the brackets to cancel out with that denominator of 6. The first one we can take a factor of 3 out, which leaves 2x plus 5. The next one we can take out 2, which leaves us with 3x minus 4, all over 6 equals 0. 3 times 2 is 6, so they'll all cancel out. And it leaves behind 2x plus 5 and 3x minus 4. This one's a little tricky because the coefficients of x aren't 1, so it might help if we write these equations separately, because we've got this times this equaling 0, so either this has to equal 0 or this has to equal 0. So we get 2x plus 5 equals 0, or 3x minus 4 equals 0, and we just have to solve these. So we can minus 5 to both sides, then divide both sides by 2, so we get minus 5 over 2. Here we'll add 4 to both sides, then divide both sides by 3, and we can get our final answer where x equals minus 5 over 2, or 4 over 3.